In other words, are artifacts that help to make diagnosis and are very easy to recognize. The second assumption says that the amplitude of the echo is related with properties of the structure that produces the echo. This is not always true. Banding sometimes is produced because in the focal area there are more intensity and echoes was produced with more amplitude. Focusing characteristics of the transducer may create a banding artifact because there are more intensity in the focal area. But remember that banding can also be produced by improper TGC settings. This is one example of banding. The transmitted wave travels along a straight line. In other words, the ultrasound pulse goes straight and the ultrasound echo comes directly to the transducer in a straight line. That is not always true, but it's an assumption that the machine takes to produce the pictures. Refraction produces change in the direction of the pulse, and when that happens, ultrasound is not straight. Refraction of the ultrasound being at a boundary between two media with different velocities cause artifact, misregistration, and bad focus. This is a typical refraction artifact that happens in the cranium of the fetus. These shadows at the side are artifacts. This is the explanation of the refraction. One pulse was produced one echo, but the pulse changed direction when get a structure with different propagation speeds. Echoes are produced but are not from the center of the beam, are echoes to other areas, and the machine cannot understand this. Refraction produces shadowing at the edge of a large curved structures, typical in the cranius on the fetus. The Snell law is the law that explains refraction, and when refraction happens, no straight line paths are in ultrasound. Other assumption is the ultrasound always travel medium or soft tissue at 1540 meters per second. This is not always true. Propagation speed, you know, is a property of the medium. You cannot change propagation speed. It's only determined by the medium, and is in soft tissue 1540 meters by second. There are different presentations of the same speed. There are different speeds in soft tissue 1.54 millimeters microsecond. But there are some times that our velocity error was produced. In this case, this is the same example of how amplitude of the echoes was produced. One echo was produced, second echo, number 3, number 4. The machine used the range equation to know the distance of the reflector. Remember, propagation speed is 1540, round trip time is different in different reflector, and with the range equation the machine put the amplitudes at different depths. But if there are something that is slow, like fat, first echo is at the correct distance, but the propagation speed in the fat is less. Second echo was produced, but happened the same. The propagation speed of the echo is slow in the fat area. And when the second echo coming to the transducer, the machine put more distance than the real distance, because the machine used the range equation, and the range equation used the propagation speed in soft tissue, and fat is slow than soft tissue, and the echo was not in the correct position. Same happened with echo number 3, and same happened with echo number 4. If a low acoustic velocity structure is encountered along the scanline path, objects are registered far than really are. This is a propagation speed artifact. Of the contrary, when the area is faster, pulse go faster in the area, echo also go faster in the area, and echoes that are behind the faster area coming before the echoes that are in normal area. That produce an artifact like this. The areas that are behind the faster areas appear near than really are. A high acoustic velocity is encountered along the scanline path to a more distant object. The object is misrepresented at more shallow depth. It's near than the real is, because the area have more velocity than soft tissue propagation speed. This is an artifact of the propagation speed. Behind this nodule there are a change in the shape of the diaphragm. That is not because there are nothing abnormal there. It's because this structure have faster velocity and the diaphragm appear curved.